Starting the live stream so that anyone who wasn't here tonight can watch. I'm not going to open up YouTube and try to watch the online stuff because it gets me distracted and I don't do the right stuff. So it's better just to be streaming. We'll figure out another way for those who are watching the stream to maybe communicate, but we'll just kind of rely on you guys here as you have questions. So if you have questions, please come to class. We'll answer the questions in class, and hopefully you're finding the live streams helpful. Either those who aren't attending class in person, finding them helpful, or afterwards, if you review them, hopefully you're finding them helpful. Okay. We've got our first issue to talk about. Does anyone know what February 19th is? And what happens on President's Day? Campus is closed, so there's no school on this day. So that takes away one of our review days. We'll take questions. We will take questions. There's always questions, but we'll take them at the beginning. Okay. So what are we going to do?
Push it back. Just not do it.
Well, we've got 2 days for review.
You just cross off exam unit 1 through 4, and I think you keep going. That's what I heard. It's like the best bet.
But then when do we do exam 1 through 4?
We can do a little quizzes.
We don't. 100%.
So get the credit for it, yeah.
Little quizzes, little tests, no? And here, and the board with the team.
Well, this is the way this works. These are department exams. We'll have, how many of these we have? We've got 3 of them. And what we're doing is instead of doing a massive final exam, we're breaking it down into, basically the final exam is broken down into 3 pieces. Yes, we could do additional quizzes, but what I'm doing with those is that's the online stuff. You can do an online quiz to kind of self-assess where you're at. And then these, what I'd like you to see these exams as an opportunity to lock in your understanding, because then once we do it, then you don't have to worry about units 1 through 4 again. Once you've passed it, we won't, it's the idea is that you master it, we check it off. So these exams are designed to be, they're only over those 4 chapters, 4 units. The next one is only over the next few ones. So we're not going to come back and revisit this information. So I look at it as, I'll work with you if you don't do as well as you want to, but we have some good review stuff that I'm going to bring. Let's see, where are we? We are on this Wednesday. On Monday, I will also have a review test, a practice test. They've got some of those, and then I might even make another practice test, but we'll get you so you're well prepared and you know kind of what you're facing. I believe each one is 25 questions, multiple choice. So you have all the answers. Just for every right answer, there's 3 wrong answers. All you get for the exam.
And how about the units, the review units that we have in the book? That will help if we study from them?
Of course, yes. And let's take a look. Let's go back to Math AS. So, I guess I got to get this out of the way. Clear it out. There's also an online review for exams 1 through 4. So yes.
Is there an answer key to that?
What's that?
Is there an answer key to that?
I believe so. Let me get in here. Sort of, because as you do it, it'll tell you whether you're right or wrong. So it's an online. I wasn't sure until it opened because I hadn't looked at it yet. So yes. So these are good ones to do. And again, this is the first time I've taught this class since the new material, so I don't have necessarily things that completely correlate with it. But I'll look at doing some kind of a practice multiple choice test, because sometimes with multiple choice you have to learn the strategies of a multiple choice, which are different than the homework questions, which are open-ended. Okay, so we'll get you to work through it all. And if you don't do as well as again, the goal is that you're all at least passing it 70% or better. My goal is to get you all 90% or better. And if not, we can work, we can remediate, I could make up another version, have you take it at a later date. Okay.
So it'll be multiple choice with the exam?
25 questions, all multiple choice. Some like to call it multiple guess, but hopefully it's not guessing, it's just choosing the right answer. So we'll practice with that, because with multiple choice, usually you can look at it and with a little bit of reasoning, you can eliminate two of the answers, because they're like one's to the two extremes, and then you got the two in the middle, and you just got to decide between those. And a lot of times you can get the right answer without actually working the problem. So we'll take a look at it.
Could you kind of do maybe, I know it's awful to say, but on Monday that we're not here, would it be possible for you to do some kind of a stream thing that we could log into, or something that you could post that you would give us, like something that we would be able to go over, and of course you would also pick maybe the word of the day, and it would show who watched it and who didn't, kind of thing, to go over some kind of practice versus like losing a day of practice, if that's something that you wanted to do.
That's a good.
I mean, just an hour of review or something.
Yeah, good idea. So what we will do is, we're not here on this day, but there will be a video for you to review with some practice problems. I will get those to you either this Wednesday in a printed version. Anything in printed version will also be available in either Canvas or MathAS, and I'll send out an email. You can print it off if you're not in class, but if you come to class, you will get practice tests. And what we don't get covered on the Wednesday, because that'll be live streamed and recorded, I will finish up in a video, and we will get them posted so you can review them probably over the weekend if you want, or on the Monday if you want, but certainly before the exam. Okay. When we have the exam, you have the full class time to take the exam. When you finish, you can leave. You have as much time as you need. Okay. Seem reasonable? So we'll get you there, we'll get you prepared. And again, our goal is to get the first third of the class locked away and done. And then we'll move forward, get the middle part locked away and done, and then do the last one, and not have to face a comprehensive test over all this material like we used to. Final exam used to be over everything. So now we're just four units at a time. And we'll get going, because tonight we're going to do a little bit of review what we did as far as lesson or unit 3, solving equations. And I'm going to show you how unit 4 is very similar. At least it used to be, so I haven't looked at it. Sometimes it's good not to look at it, because I want to look at it with a fresh eye too. But I've looked at it a little. So we'll do that. Does that make sense? Okay, so that's what we're going to do. Is here will be, looks like I've crossed that out, right? But that's that in practice tests. Okay, and there'll be practice tests available on Monday as well. I'll just put PT. So if you come on Monday, I'll have printed versions of a practice test. And Wednesday, I'll either have additional, or if I haven't, it might be enough. We'll see. We'll kind of play it by ear this first time. And then, yes, I'll follow up with videos that if you've got time on the Monday of the holiday or the Tuesday, whatever, you can watch those and see the problem solved. Because that's, by the time we get to the test, it's really not having to discuss things. It's working problems, working more problems. Okay. So let's get started with the word of the day. What's our word of the day? Macaroni. Do we get any cheese with that macaroni or just the macaroni? Just macaroni. Mac. Now you gotta. Macaroni. Yeah, thanks. 2 C's or 1? Macaroni. That's what I would have spelled it as, but I.
That would be it.
That's correct. So good. Spell check. I would have. I was going towards 2 C's, but that's macaroni. So now, verify that you've attended. There'll be a little attendance quiz. Macaroni's our word. Okay, good. Actually, I grew up, when I was a college student, this is how I got through college. Macaroni and cheese and a can of tuna fish. You put the two together, you got a casserole that you could do in a microwave. Okay. Even if you didn't have the milk or the butter or stuff. It's kind of chalky, but you know, hey, it was like 50 cents. And actually back in the day when I was the early 80s, it was 25 cents for, you know, serious, you know, I don't know. You guys think you got it hard. The 80s, it was hard being a college student. We didn't have all this technology stuff. Okay. So we're going to take a picture of that. And how many of you have looked at the videos since I've been posting them with the notes? Anybody? You have? Are they good?
Yeah.
Okay. It's okay. So I'm taking these screenshots. Actually, we're already to page 2, but that's okay. The screenshots, so right underneath the video are screenshots with, so, you know, if you just want to look at them, sometimes that's enough to remind you of what we did in class, the notes. It allows me to just kind of get a new page here, and then we'll move on to a few examples. Okay, so let me just move this out for now, and let's look at a few examples from lesson 3, and then I'll entertain any questions that you might have from lesson 3, and then we'll just kind of dive into lesson 4 and see how it's very similar. So what did lesson or unit, I guess I should call them unit. Oops. Sorry, I forgot to move the live stream over to here, so those who were on the live stream, you'll just have to catch up later with the screenshots. So that's where the screenshots help. They weren't seeing anything that was up there. Unit 3. Okay. Does anyone remember the title of Unit 3?
Solving for X.
That's a good alternate. Solving equations, which really is solving for X. Sure, sure. So solving, that's the key part. And what was the, so they're solving equations. Equations have to have what? An equal sign. And what did we say sort of an equal sign sort of represents mathematically? Balance. So we're going to look at it sort of as the balance beam. The left side and the right side are equal. So whatever's on the left, whatever we do to the left, we have to do to the right. And that way we keep it balanced. Okay. Looks like a nose and 2 eyes, but okay. So we started off with something called the one-step. One-step equations. And that was something like x plus 4 equals 3. And how did we solve the one-step equations? Set? Minus 4. So we always did the opposite. So we were, if we were subtracting 4, we would have added 4. But since we're adding 4, we subtract 4. So it's doing the opposite. Look at the story of x if you want. We're adding 4 to x, so let's subtract 4 from x. And that's how we solve. We solve by doing the opposite. And we do it to both sides. And so then we get x. And remember, plus 4 minus 4, that's 0. That's what cancels out. So there's my big 0. 3 minus 4, signs are opposite, so we subtract. 4 minus 3 is 1. The 4 is bigger, so it's negative. Done. You can go back, take the -1, plug it in for x to do a check. -1 plus 4 is equal to 3. So you could do it mentally, or you could actually write it out. Okay, so that's kind of what they had you do. Another example of a one-step equation might be something like 3x equals 15. What would we do to solve this equation?
Divide 3.
Divide by 3.
Okay, since we are multiplying by 3, we do the opposite and divide by 3. Good. So always kind of, oops, not 2, 3. So always look at what's being done, do the opposite. Do it to both sides. Okay, 3 divided by 3 is 1, so that leaves us x on this side. 15 divided by 3 is 5. So we're left with something like that. So those are the two versions or two examples of a one-step equation. So far, so good? Okay. We could do fraction. We could, but we'll get our chance to work a lot of different examples as we go into our review section. After the one step followed the two-step. And two-step equations were basically the same thing, but they might be sort of like a combination of a multiplication and an addition or a subtraction. And what would we do on these kind of equations? Since they're two steps, how many steps do you think we're going to take? 2. Is that too obvious? Good. So, but what's the key part of this? Which step do we take first? Do we take care of the multiplication or do we take care of the addition? We do, right, because we're doing it backwards. We reverse the order of operations, okay? Because we're solving. We're taking the engine apart rather than putting it together. Okay. So again, on this one, we would take care of the addition part first by doing the opposite, and again, doing it to both sides. This part is 0, so it cancels out. 5 minus 4, this is a positive 1. And then what's the next step to do? Divide by 3. We were multiplying by 3, so the opposite would be to divide by 3. Divide by 3 on both sides, and we're left with x, because this is 3 divided by 3, equals 1/3. That's just the answer. Now you could write it as a decimal if they ask for it that way. 1 divided by 3, you plug in your calculator, you get 0.333 forever. And we could round it off at some place. Make sense? Two-step equations. Very good. And what followed two-step equations? Could it be three-step equations? I don't remember any three-step equations. Going to need some room, so we get us a nice big page. Does anyone remember what they were called?
MultiStep.
There we go. I guess it could be 3 steps, but it's also saying it might be more than 3 steps, so they just said multi-step. So the multi-step, and remember, usually I would take probably 2 class periods to go this far. Multi-step. So we're just kind of doing this. What was the key part of the multi-step? If you remember those. What's that?
The order of operations. You have to
What do you mean by that?
have variable on one side.
Okay, so the main thing was it's what made the multi-step was we would have something with a variable on both sides. What is it doing here? Okay. So we might have something like 3x plus 4 and 7x minus 8. So we've got x's on both sides. So before we could start doing anything to kind of get x by itself, we first have to get x to it together. And so what was the approach we took to get x together on one side?
You have to eliminate one.
Eliminate one by doing what?
Finding the common.
Variable or non-variable?
Well, how can we get rid of something in math?
You have to subtract.
Sometimes we have to subtract, sometimes we have to add, but what's the result we're looking for? What are we trying to make?
Zero?
0. We're looking to try to make a 0. Because 0 is nothing, in a sense. It's something, but it's nothing. So those were all good comments. Those are right. Sometimes we subtract, sometimes we add. We don't divide or multiply because that's the only way you can make 0 that way is to multiply by 0, but then everything's gone. So looking at this, we're going to either subtract 3x to make 0 on this side, or we're going to subtract 7x to make 0 on the other side. Which one would you like to do?
3x.
3x. Why? Why is that the better choice, at least according to Little Crow? And according to you?
Because then you'll be working with a positive and negative.
Very good. So we're looking ahead. If I subtract 7x from both sides, I'm going to end up with that x is going to have a negative on it. Because over here, 3 minus 7x, 3x minus 7x, that's going to be negative. So if you look ahead, it'll help you. Also, if you want to just say, well, the 3x is first, that's fine too. But we subtract 3x from both sides. Can we do that?
Yes.
Why?
Because you're doing it to both sides.
Because we're doing it to both sides. As long as we do it to both sides, we can do anything we want. Okay? Good. So again, on one side, the left side, it makes a 0. So it's completely gone. All that's left, though, is this plus 4. You could just write it as 4, but I'll put the plus. Okay. On this side, on the right side, 7x minus 3x gives us 4x. Good. And then what happens to the negative 8? It just comes on down. Nothing. Now we're back to doing a two-step equation. Okay. So this just takes us back to what we've already done, and we'll work it through. But that was a critical step. So you notice we went from a one-step, the two-step, we added another operation, which is to have multiplication and addition involved. The multi-step, we had to get the x's together, and then now it's a two-step. And the other ones after this, maybe there's some parentheses, so we have to do some distributing. So we can look at some other examples that you might have had. But on this one, we would just now come and say, okay, the next step, let's add 8 to both sides. Because now we're trying to get the x by itself. So we get rid of everything either by making zeros, or when the multiplication's involved, we make ones. Okay, so first we get rid of this part, so that becomes 0. On the left side, we get 12, 4 plus 8. And on this side, not plus, we need our equal sign here. And let's see, what did we say? That was 4x. Okay. And now what's the last step we need to do? This is 4 times x, so we divide by 4. And that's pretty good. I ended up with an even answer, and I just sort of made up the numbers as I was going. So I like to show you that you know we don't always have to end up with an even number as our answer or an integer. But 12 divided by 4 is 3. So if we plug in 3 for x at the original one, we should get both sides are equal. So that's a way we can, that's the nice thing about this unit, is that we're able to check our answers. Once we've got it, we plug it back in and see if it worked. See if both sides are equal to each other. Is that about what you remember from Monday?
A little bit,
Little bit.
just a little different.
Okay. Monday was so far away, right? So much has happened. And that's true these days. Sometimes it's like our world has changed in just 2 or 3 days. Okay, but what we're going to do is well, does anyone have any questions that came up from either the online homework or the practice problems, something you were working on that didn't seem right or that you weren't sure how to do? We could work out in another example or two, say in the next 7.5 minutes, and then we'll move into 4, so we get a good shot. We do more than 7.5.
Do we have basic calculators for the test?
Sure, you use calculators. Always use calculators. If anyone says you can't use it, well, maybe I shouldn't say this, but I will. I strongly believe in the use of calculators, and usually when people say you can't use a calculator, they don't have a good reason for it. If they have a good reason for it, then I could see. But usually they don't. Like the SAT, the high school test, they didn't used to allow you to use a calculator. And then there's a lot of research that did why, and they couldn't. They just said, well, that's cheating. Why is it cheating? Nobody could answer it. So eventually, I think you can use it on the SAT now, and other tests, the same thing. They do limit because some calculators have memory and stuff, so they're worried. You know, like some of the online tests, GRE does one. They have a built-in calculator, so they limit what you can do with it. I guess that's okay. But to be able to do basic multiplication, addition, subtraction, and division, I think that's what we get used to doing with math. So yes, you can use calculators, and you can use this fancy. If you can figure out the really fancy ones, more power to you. There are calculators that will do algebra, but if you can figure it out, you're welcome to use it. TI-89, it's like it'll do all the algebra stuff too.
Oh, yeah.
So, good. Anything else? Are we ready to move into 4? You ready for 4?
Yes.
Scary. But remember, 4 is going to be the same thing as 3, except that one side's bigger than the other. Okay, we got one of these for it. So it's not too bad. Nothing to be scared of, right? Of course, that's what Willy Wonka said as he took him down that river thing, right?
Oh, yeah.
That was pretty scary, I thought. Okay. So now let's pull up our, where is it? Here it is. So let's go into inequalities. Let's just pull up the student workbook so we can kind of see, and hopefully you've taken a look at this and maybe watched a few of the media lessons on inequalities. And they do take you through some, some good stuff step by step. First thing we're going to work through, I guess, a little bit. Make this a little bit bigger. There we go. Full size. One of the issues that some people have with these inequalities, bring it down a little bit, is they are directional. So if you have some reasoning problems or some mental, the left brain, right brain sort of thing of size, if you mix up left and right, like you're dancing and you're supposed to go left and right. I mean, there's some people who can dance the male part and the female part because it's, who's the leader. I always need a good leader because I need someone to follow because I mess up the leader's part, whatever that is. And when I'm supposed to go left, I, for some reason, go right. And a lot of times you'll see me when I walk and the thing that you do when someone's walking towards you, you step to the left, they step to the left, or maybe it's the other way around. But you're trying to get out of each other's way, but every time you try to get out of their way, you end up like mirroring them. your brain's telling you to go the other way, but then you follow them and something. So those kind of things are thinking abilities that don't work well with inequalities because we get it backwards. So first of all, as we look at this, which side, so that we're going to take a look at this symbol. What is this symbol? How would we call this if we were reading from left to right? This is the less than. And again, there's probably a media lesson that takes you through it, but this is not anything. So what I'm going to do is this side is the small side. I'll just put SM. And that means the other side is the large side. And it doesn't have to be too much larger, but one side's bigger than the other. The point, it sort of points towards the smaller. The open end is towards the big side. Some people call it the alligator, and the alligator is going to eat the big thing. I like to think of the funnel. The funnel points towards the small thing. You know, you got your ketchup bottle, you want to put a funnel on it, you know, so you're trying to funnel something in. I see more of a funnel than an alligator because I was always scared of the alligators. They were at the bottom of my bed. Anyone have alligators at the bottom of their bed? Yeah, when my stuffed animals didn't behave, they got fed to the alligators. So probably revealing too much right now, but that's how it was. Okay. How is this one different? The next symbol. Less than or equal to. It's really two symbols. It's got the less than symbol with the bottom half of the equal to. So it's got two things it could be. It's either one side is smaller than the other, or they could be equal. Okay, so this is read less than. Or equal. Okay, so again, if one side is smaller, this will be the small side, and I'm going to underline it, say or equal. And if the one side is larger, it's the right-hand side, so this is the larger side, and I'll underline it to say or equal. Okay, so they could be equal, but one side, the left side, could be smaller than the right. So far, so good. And again, you'll just get it with practice. Me slowly talking through it isn't going to necessarily change everything, but it'll help, hopefully, to develop a way of looking at it. So this one must be the opposite, greater than. And again, it just switches. This one, the large side is on the left, the small side is on the right. And as we're going through, we see the next symbol, also a greater than, but also has part of the equal sign, so greater than or equal. Okay, and again, if one side's going to be large, it'll be this side, but they also might be equal. And this side would be the small side, or it may be equal. So far, so good. And the last type of inequality simply means not equal. And this is the best kind of not equal. It simply means not equal. Okay. Not necessarily D and E. It's really stating a relationship. We don't know which one's larger or which one's smaller. All we know is that they're not equal. Okay, that's just not equal.
Would that be used more with letters than numbers? Like if it's X not equal to Y or O?
You could, or 0. A lot of times you'll see X not equal to 0 because we won't do it in this class, but in some classes 0 causes something to become undefined. Division by 0 is undefined. So they'll say, well, X could be anything except X not equal to 0. We want to exclude a number. So that's typically what that symbol is used for. Yes, you put a variable and you put something that it's not equal to, saying that basically it can be anything except this for some reason. And again, those of you going to 120, you'll see its use later in that class, not so much in this class, not at all in this class. But definitely in 121, 150, college algebra, you'll see that used quite a bit. Or, I don't know, a bit, but you'll see it on a regular basis. Okay? So I gave my examples there. And again, so then they give you some, x greater than 1. What does that mean?
Means x could be 5 and it's greater than 1.
Good. Could be 5. What else could it be?
Could be 2.
Oops. Could be 2. What else could it be? How about 1.01? Yeah, 1.01 is bigger than 1. Just a little bit. Well, maybe not according to that guy. See, sometimes the live stream, I don't know if you heard that through the walls, but we heard it here, so we had fun. Okay, so I'm going to go, let's go here, and we'll just sort of, we'll take a look at a few of these. Because I also want to introduce you to the interval notation. So we have inequality notation here, x is greater than 2. So what would the, I don't know why they had 2 graphs. I don't know. Why do we need 2 graphs to graph one thing? Maybe if you watch the media lessons, maybe there's a reason for it, maybe there's not. So what does x greater than 2 mean?
It's a number larger than 2.
So a number larger than 2. So again, this is kind of open. You could put your 0 anywhere. Let's maybe go here. So this is 1, this is 2, this is 3, whatever. So where is x equal to 2? It's right here. Is x equal to 2 included in that?
No.
No, it doesn't have the equal part. So what we want to do here with the graph is we'll put an open circle. And then x is greater than 2, so does x live to the left or to the right? To the right. X is bigger than 2. That's the way we kind of want to read that. And so we just sort of shade x can be anything over here. It's any number bigger than 2, but not 2. Okay, so that's what the graph would look like. Interval notation, what we do is notice we've got 2 endpoints. We've got infinity here and 2 here. So the way we write this as an interval, just a space from beginning to end, is we will write this as 2 to infinity. And then we'll use one of 2 symbols. We'll use either a parentheses or a bracket. A parentheses means the endpoint is not included itself. It's sort of like an open endpoint. So did we agree, is 2 included or not included?
No.
Not included, so we're going to put a parentheses. And we'll see the next one, how that changes. How about infinity? Can you ever get to infinity? The concept is not. If you're there, you're not at infinity yet. You still have further to go. You got to keep traveling. So the idea is we never get to infinity, but I think it'd be a fun place to get to. Anyone else want to go to infinity with me?
And beyond.
And beyond. Infinity and beyond. It's got to be a cool place. They say you can't get there. I bet you there's a way. So anyway, we're looking. So far, so good?
So are the brackets then just saying that you're staying in this zone?
Not
this
staying,
place?
but that particular spot is included as part of the answer. And we'll see. So let's go to this next example, and you'll see this one's going to have a bracket on one end because it's included. So x greater than or equal to 2. So x could be equal to 2 here. But in the one above it, x cannot be equal to 2. It doesn't have the equal part. So this is going to look very similar. Again, you could label them. I like to just jump and say, here's our 2. Instead of an open circle, we put a closed circle saying 2 is included. 2 is part of our answer. And then again, x is greater than 2, so we sort of shade this side. And we have our 2 endpoints, infinity and 2, and we always list our endpoints from smallest to largest. Okay. Infinity will always have a parentheses because again, sort of you can't really get there. But in this case, the 2 will have a bracket signifying that the 2 is part of the answer, part of the solution. So it throws in just one more point because anything bigger than 2, we could go 2.00002 or 1 or whatever. Just anything a little bit bigger than 2 is included in this first one, but not 2 itself. The second one has everything bigger than 2 plus 2. It has one extra point in it, but it's a detail that we need to consider. And why? Let me give you an example of something that should hit home. Let's talk about grades. What do you need to get an A?
90 or better.
Why? Because that's what they say, right? I always wondered why. Nobody ever told me why, but they said, well, that's what you need. Then what do you need to get a B?
89 or
80 to 90. Oh, wait a minute. Which one is, if I got 90, do I get a B or do I get an A?
you get an A.
You want it to be an A, right? So what we do is if you got the 90, it's included in the A part. It's not included down here. It's sort of like right up to 90, but as soon as you got 90, you jump up to an A. So 89.9999 is still a B, but you get to 90, you jump up to the next level. Does that make sense? And the same thing, the difference between a B and a C, and again, you could list it different ways, but 70 to 80. But again, if you got 80, you don't want a C. You don't want a high C. You want to have a low B. And there's nothing low about a B, right? So this is where we would use it, is sort of on overlapping intervals. Does that make sense? Sort of. Okay.
I always thought it was 80 to 89.
So, and some people do that just to
Clarify it.
clarify it, but then if you got 80, you know, if you can use fraction or decimals and stuff, then what do I do with an 89.5? Well, is that an A? And again, some systems are very strict, and okay, you have to get at least a 90. So 89.99 is not an A; it's still a B. If you're going to go for that much precision, I would round it up. But yeah, sometimes in the mathematics, we don't want to leave anything behind. So if I go 89 and then 90 is an A, there's this whole like point that's not assigned to anything. So to be completely unambiguous, but you know, we can figure it out, right? So yeah, some people would list, and again, I have nothing against people who would list 80 to 90, or sorry, 80 to 89, and then they'll figure out what happens with, you know, 89.5. But this is another way to do it, another application, where one side is included and one side isn't. Okay, so that's that idea. You do this like it used to be like cell phone programs, or you would pay like for 500 minutes, and then after that, you know, that was included in a plan. If you used over 500 minutes, then minutes started, you paid per minute for so much. A lot of plans now are unlimited, or you pay for the minutes from the start, but that's the concept. What happens at 500 minutes? It's either included in the lower half, or 500 minutes is when they're going to start charging you. But it can't be included in both sides. Okay, enough of that. These are like, see, I told you this is, you're going to see real quickly. It's going to really be the same thing with a few semantics, and that's the thing, is because greater than, less than gives us this kind of weird thing that happens right at the boundary. It's like if you own property and you've got a neighbor, who owns the fence? What's that? It's usually on the property line, but if you look at it, I studied real estate. Actually, I'm a real estate. I took the real estate test, so you have to go through all this stuff. A fence belongs to one of the it's whoever's side it's on. You cannot actually be on a property line, but it also determines that if you own the fence, you maintain it, and your neighbor's property starts at that fence. And so it's kind of a way, if you're a little scrupulous, you can actually steal your neighbor's land because you move it over a few feet. And this has been done, and if it goes on for 10 years without being, you know, it's kind of like you can still land that way. So you got to be careful about fences, but fences belong to one side or the other. Okay, fences always do. One of the properties owns the fence. You may decide to be good neighbors and share the cost of it, but be careful if your neighbor comes over, I'm going to build a fence. It's still his fence. Even though you paid half for it, you were a nice neighbor and did that, that neighbor that built the fence still owns the fence. So if they want to tear it down, you say, well, wait, half of it's mine. No, when you build a fence, one person owns it. Okay, so that goes with so one property has all the property plus the fence. The other side goes up to the fence, but the fence is not theirs. That's another application of this. Okay, so this person, this is the property that does not own the fence. Okay, they own all the way up to the fence. I don't know, oh, this is kind of cool. Turn the blue to yellow. All these cool things. So again, we're at 2, but this time we're less. Can you see that very well? No. It's cool, but since no one can see it, it's not that cool. Okay, let's see. I think I can I turn this whole thing? No, it's not doing the trick again. So do this. Here's a 2. And this time, which way is X going to live? Left or right?
Left.
It's to the left. 2 is not included. This time we're smaller than. So what's our interval going to look like? Negative infinity to 2. And again, we always list smallest to largest. Did you ever think of infinity being small? It is when it's negative infinity, I guess. It's the smallest number there is. Again, the 2 is not included. Negative infinity is not included. Okay. And watch this with MAT091. They'll ask you these questions. You got to get the order right. So negative infinity is an incredibly small number. Very, very negative. Way off to that side. But the 2 is, so that's how it is. Okay, so far, so good. How about this one? What does this property owner have?
Part of it, but
Yes, or equal.
They own the fence, and they own the property as well. So they own the boundary. That's what makes them different. So again, the boundary is still going from negative infinity to 2. This time we get a bracket. And does not kind of look more like a fence than a parentheses. So you could think of it in that terms. Again, negative infinity, the concept is it's a place we can never get to. And I don't know if you want to think of it as small or something, but negative numbers are just a different direction than positive numbers. That's the other way you could think of it. So far, so good. Questions? Bless you. Okay. So now let's go ahead and it's our major things. There's different applications of it. You'll see some others where they give you the interval, write the graph, write the inequality. Here's the graph, write the inequality, write the interval notation. Feeling okay about these? Let's get into solving, because this is where we're going to do all of them anyway. Okay. I find sometimes it just makes more sense once we get here. Okay. So, oh, they went to the hard ones right away, but we can handle it. Okay. If this was an equal sign instead of a, so we're looking at example 1 now. If that was an equal sign instead of an inequality sign, what kind of a problem would we call this one?
2-step.
2-step, actually one more step.
No, it's multi-step.
It's a multi-step because there's X's on both sides. But you're right, then when we get done, it'll only be, it's really only 2 steps, but okay. X's on both sides. So let's see if this works. We'll just treat this inequality symbol as if it were an equal sign. We'll just keep writing it down and see if things work out. So what would be the first thing we did? We've got 3x on one side, we got x on the other, and plus 6.
Combine the x.
Combine the x's by doing what?
subtract the 3x from each side.
We could subtract 3x, but
Then keep it.
we want to keep it positive,
Subtract x.
subtract x. And you're going to see why we want to keep things positive, especially with inequalities. It makes things so much nicer. So we will subtract x from both sides. 3x minus 1x, 2x. We get the inequality, just copy it down. X minus x, that's 0. So we don't even write that down, it's disappeared. And then what's left over on this side is plus 6, or just 6. Is x by itself yet?
No.
No. It's got a 2 there, and what's happening to the x and the 2? Multiplication. So what do? Divide. Cancels on this side. We get that x is greater than 3. So now we're going to be asked, and that's our answer. That's what our answer looks like now. It's not just that x is 3. It's x is any number that's bigger than 3. And actually, is 3 part of our answer? It's not, because it's not equal to 3. It has to be bigger than 3. So on our graph, I just come here, and let's go ahead and put 3, because that's the boundary. Is 3 included?
No.
No, so we put an open circle. And then which way is x? Is it to the left or the right?
Right.
It's to the right because it's bigger than 3. So if you're bigger, you go to the right. So I just kind of shade this way. So that's what the graph will look like. So what's interval notation going to look like? The boundaries are at 3 and infinity, parentheses on one side, parentheses on the other. Doesn't that look a lot like what we were doing in lesson 3? Except instead of having an equal sign, we've got this inequality. And that's exactly the same thing. It's not balanced, but we maintain the imbalance by doing the same thing to both sides. It will work all the way through. There's just going to be one thing to look out for, and I'll see if it comes up or not. We might be able to avoid it a lot, but if it does come up, we'll take a look. I should have gone up a little higher. Let's take a picture. Let's clear this one out. Okay, a definite multi-step one here. You want to look at 2, you know what, you've got videos you can watch on these. How about we go to look for like a U try that's kind of hard, like B, because this one there's no video on, right?
Sorry.
We can do B, we can do any of them, I guarantee you that. And we can do this, right? So we'll walk through this one together. We'll record this video so we can come back and review it if we need to. But this, if you can do this, you've got this unit down pat. Okay. Let's go with violet. Okay. So we're looking at this. We've got 2 sides. We've got this inequality. Looking at this, any suggestions on where to start?
Distributed.
Distribute the 5. Okay. You could divide by 5, but then you'll end up with fractions. So again, there's a lot of things we can do, but sometimes things will make things more difficult. Okay, so 5 times 2, and then 5 times 3. 5 times 2x,
10x.
10x. 5 times negative 3,
Negative 15.
good. And then we've got the inequality symbol there. We just write it down. Don't mess with it, don't flip it, don't do anything. It's just write it down. And then on the other side, we've got 6x plus 13. We didn't do anything on that side because there's no parentheses, nothing to distribute, nothing to do. What do you notice about this problem? Okay, so you see x is on both sides, and you want to do a negative 6x. Why do you want to subtract the 6x and not the 10x? To keep the positive. Good. So I always want to, we could subtract 10x from both sides, and if that's what you're leaning towards, you could go ahead. And we might do it, But I'll show you it does create a problem. And we have fewer problems if you keep things positive. Isn't that the truth of the world? If we could just keep things on a positive stroke, we would have a lot fewer problems. Happy people who are well-fed, well taken care of, usually don't start revolutions. It's the people that aren't fed, the people who don't have, and they see a bunch of people who do have. That's when we have revolutions. And that's when we need revolutions, believe me. But when everyone's taken care of, okay, I know, this is not a social class, but there's political justice in math as well. So keep things positive. So plus 13 is all that's left, right? Because this went away. 10 minus 6, as was promised, keeps it positive. Positive 4 minus 15. Okay, what would we do next? Add the 15. Very good. So I'd like to do multicolors here. So our next step, we'll add the 15 because that gets rid of that. Add the 15 here. So 15 minus 15, that's gone, that's 0. So we get 4x on this side. 13 plus 15 is 28. And notice the inequality sign is just coming down, just like the equal sign did when we were working in lesson 3. We're just doing the same thing to both sides. We're doing the opposite, and we're making it all work. So what's the last step we need to do here? Divide by the 4, because we want the x by itself. Good. So we divide by 4. Divide by 4. And again, on the right-hand side, 4 divided by 4 is 1. The inequality sign stays the same. 28 divided by 4 is 7. There's our answer. Now, some of you, does any of you feel uncomfortable because the x is on the right side and the 7's on the other side and it looks kind of weird? Not that weird, huh? I think it looks weird, but you just get used to it. Which side is the bigger side? What's bigger, 7 or x?
Yes.
X is bigger. That's really all you got to do. Is that's a relationship symbol. We know x is bigger than 7. So when we come to our line, our number line, we just put in the boundary of 7. We know that x is going to be bigger, so that means it's to the right. So we shade that way. Is 7 included in our answer?
No.
No, there is no equals part of this, so we put an open circle around the 7. Open circle means a parentheses, means 7 is not included.
How do you know that 7 is not included?
If it was, it would have looked like this. This little line makes the difference between included and not included. Okay, good question. This one, not included. So in this case, the symbols that go together, this one goes with an open circle, which will go with a parentheses. This one goes with a closed circle, which will become a bracket. Okay, so when you have this little equals, that's how it's going to work. When we don't have the equals, it's an open circle, and then our interval is from one boundary to the other boundary, and then parentheses because it's not included. How was that? And again, that's about as nasty as it gets. I mean, if you could do that one, you could handle. We could make it a little bit more, put a few terms in there or something, but it doesn't get much. It doesn't get much worse than that. Okay. Take a picture. I think everything's working well. Okay, make sure I record. I hate when I do all this and then I say, oh, I didn't start the recording, you know. I just made the perfect video, but the machine wasn't on, right? Okay, now it's going.
So taking a good picture with the lens guys on.
There you go, yeah. Okay, so I'm gonna clear this out and let's just see what's next. And there's really one more thing I do want to cover with you. So yeah, we're to applications 4.3 already, which are just word problems with inequalities. We'll take a look at a few of these, but before I do this, I want to show you the reason we have been avoiding negatives if we can. Okay, and I'm going to give you one that has a negative involved that we can't do anything with, sort of. So before we do this, let me just do this in a concrete manner. Someone give me a number, just so you know I'm just not making this. Any number. 18. It's 2 digits. That's big. I'm scared already. 18. No, that's not big. Someone give me another number. 3. Good. That's smaller, nicer, easier to deal with. All we needed was these 2. What's the relationship between the numbers? 3 is less than 18, or if I read it from left to right, 18 is greater than 3. Or you could read it, that's the nice thing, you can go both ways. 3 is less than 18, that's true. Okay, so that's cool. Let's test this out. Because I said we could treat it like an equal sign, what's going to happen if I like add a number to both? Someone give me another number. A single digit number. 6. What if I add 6 to both sides? What happens? 18 plus 6 is 24. 3 plus 6 is, what's the relationship?
Still greater than.
Still greater than. Okay. Let me rewrite it. 18 greater than 3. What if I subtracted 6 from both sides? What happens? 18 minus 6. 3 minus 6. What's the relationship? 12 is still greater than negative 3. (18) greater than 3, you all agree? What if I were to divide both sides by 3? (3 divided by 3? 18 divided by 3? What's the relationship?
6 is greater.
Still greater than. Nothing happened there, no fancy stuff. One more thing to look at. We're still, okay. 18 is greater than 3. What have we not looked at yet? What's that? Multiplication. Let's multiply them both by 2. I don't want to go too big because I might not be able to make the 18 times. 18 times 2 is 36. 2 times 3. 3 times 2, 6. What's the relationship? Still greater than. So Little Crow told you that working with inequalities would be just like working with equals. And so far has he been true about to his word? We can do anything to both sides as long as we do the same thing to both sides. We have maintained the inequality. But he also, just before this, he mentioned that there was one thing we had to worry about. Obviously, we don't have to worry about adding, subtracting, dividing, or multiplying. Can anyone think of what it is that we do need to be careful about? That's why we were avoiding the negatives, right? Because what's going to happen with negative, well, obviously subtracting a 6 didn't cause a problem, but what kind of negatives are going to cause problems? Let's multiply, and let's just take my favorite negative, -1. Let's multiply, I'll do it with a parentheses, let's multiply both sides by -1. Because you could also divide both sides by -1, right? What's 18 times -1?
-18.
What's -1 times 3?
-3.
What's the relationship between these two? -18 became smaller than negative. Yeah, the inequality has changed directions. When we multiply or divide by a negative number, the inequality will change its direction. This is something very powerful, because if you could figure out how to take a -1 and multiply it by your debt, what would happen? Not only would your debt be wiped out, but if you owed $1 million, you now have $1 million. Isn't that true? A -$1 million debt, because I'm just, the problem is we keep borrowing money, but borrowing money is we're subtracting from our wealth or adding a negative. It just gets more negative. Believe me, I tried it. You can't borrow your way out of debt. You just get more debt. But if we could find a way to multiply our debt by -1, we'd simply be like really wealthy people. We'd go from owing millions of dollars to having millions of dollars. This is the mathematical property of the negative. Of course, it could also take someone like Bill Gates, who is like one of the richest people in the world. You multiply his wealth times a -1, what happens? He now owes a lot, so okay, he's broke, more than broke. Okay, so a negative has, a negative, just that little -1 has so much power when we multiply. It is really reversing the order of things. It's taking something that's huge, making it very small. It's taking something that's very small, making it huge. Okay, so, and just with inequalities, we just have to remember this, that's the property. So if there's an instant where we ever had to multiply or divide by a negative, we have to remember to flip the direction of the inequality. Okay, so that's what I wanted to take a look at this one example. -3x is greater than 15. That's what we're given. How would we go about solving this, or to get the x by itself? What have we been taught so far? We would divide, because we're multiplying, right? But what would we divide by? -3. When we divide by -3, what is it going to do to the direction of the inequality? It's going to change it. Now, it's not as obvious here because there is this unknown, this x, right? This cancels out. -3 divided by -3 is 1. And 15 divided by -3 is -5. So we can't really compare, but we just have to know that in the process of dividing by this negative, that it has really reversed. It's made the big things small and the small things big. It has changed the direction of the inequality. So this is one thing you have to worry about, and I think there's a few in the homeworks that are set up to force you into this issue, that when you're going to need to divide at some point. We'll do our best when we were working, and if we're careful, we can avoid this problem most of the time. Do it in a way to get the x's together where the x is positive. That's why I wanted you to do that, because then we don't have to worry about this. But when it does come up, it's not that big, you just flip it. The problem is, I'll get students who every time they divide, they want to flip the symbol. Because it's kind of fun, isn't it? I don't know. But it doesn't get flipped every time. You notice over here, the symbol never changed direction. There's only one case where that happened, and that was either multiplying or dividing by a negative. Okay, so that's the one issue. The only thing that's different between inequalities and equalities, equal sign, is the division or multiplication by a negative. and then we just have to switch the symbol. That's all that really is. Everything else will work exactly the same. Pretty sure. As much as I know. If you find an exception, let us know. But I haven't found one yet. But doesn't mean there isn't one. So sometimes it's harder to prove there's no exception. Okay? So let's, well, we got these, where are we? We got enough time. Let's take one look. Clear this out. Let's look at one of the applications maybe, and let's see if I can find one that's sort of got that set up. Okay. So I told you I would show you how to set up, how to do word problems, right, without actually reading. Because everyone says just read it and read it again, and read it 3 times or 4 times and then do it. I said don't even read it. Okay, so there's a lot of words here, right? I'm going to show you how to do this one without reading it, at least not initially. I read at the back side. Okay, so what's the first thing Little Crow's going to do? If he doesn't read it, what's he going to do?
Look for the numbers.
Look for numbers, and you can do it in any order. I just see numbers, I underline them. Ooh, good, 3 numbers there. And then I also look for math words. Oh, here's a math word, inequality, italicized. Do you see any letters? I don't see any letters. Okay, so maybe we get to make up our own. So those are the first things I do. What's the next thing I do? I look, what's that?
I was gonna say write them down. Write the numbers down separate.
Oh, we'll do that, but actually before I do that, because I don't know what I'm going to do, actually with the numbers, sometimes I'll take their units, so this is a per week thing, so I saw that. Okay. What I'll do is I'll look at the end, because usually the last sentence tells you what you're doing. That's where the question is. So it's always, I find if I know what I'm trying to answer, I know what to write down and maybe what to do. Okay. So this last one says, solve the inequality, write your answer. Maybe we have to go further back. Here's the question word, determine. Determine means we have to do something, right? So write an inequality that can be used to determine the number of computers Sam needs to sell in order to make a profit. Okay, so now, see, I haven't even read it yet, so I don't know who Sam is or Sean, and I don't know anything about computers, but now what I'm going to do is now I go back and read it, and yes, maybe you take a few notes, $2,700 per week, and $600, and what is the 600? Oh, it's to produce, so that's a cost. Okay, so this is kind of now starting to make sense because I read something about a computer and making a profit, so cost must be like a negative thing. So this is a cost, 600 for a cost, and then oh, 1,500 sells. Okay, a computer sells. So notice I'm looking at my numbers and I'm picking out what they mean. So this is like a price of a computer. But what I've done is, remember when my first day, how many remember my first day presentation? I had a picture of the brain, right? What was in the brain that causes some math problems? Do you remember it started with an A, an amygdala? The amygdala. The amygdala is where math word problems come in. And what else does the amygdala do? Emotional memory. When you start reading a word problem, your emotional memory comes back. So if I would have started reading this, Sean owns a business that builds computers. Oh, you know, I remember this friend who had this business about computers and they went bankrupt. And then I go on this tangent. I'm not even thinking about a math problem anymore because I'm thinking about my friend who went bankrupt in the computer business. You know, all these things start happening. What I start doing is I get into the story. If I have issues with emotion, they become greater. When I pick out numbers, I'm not all that emotional about numbers. They're just numbers. And I've avoided the story part of it until the very end, but I know I've got some numbers to work with, and I know I'm trying to make a profit. Okay, so now as I read through the story, I'm less likely to get sidetracked because I know where I'm going with this. If I start reading it at the beginning and don't know where I'm going, I start making my own stories. This is natural. This is what humans do. Okay, we have empathy. We start feeling for Sean. Is he going to make it in his business? All this sort of stuff. But we bypassed all that by starting with the numbers. Okay, so now I can read it with less emotion. The fixed operating costs for his business are $2,007. So those are fixed operating costs. So he has to pay that much each week, right? So this also is a cost. I just picked that up. I didn't know that before. So that's a cost per week. In addition, addition, there's a very nice math word. What does addition mean? Add. So I was given this number and I'm going to add to it what? In addition to fixed operating costs, each computer costs $600. So I'm going to add $600 for every what? So if I had 2 computers, what would I add? 600 times 2, 1,200. If I had 3 computers, 600 times 3, 1,800, right? So in general, if I have X computers, see, I'm starting to build my equation right from what I've written down. 2,700, that's the cost, plus 600X. And X is my number of computers. Could you see if you want? Computers. Oops. You'll get it. Okay. Okay. Each computer sells for 150. So what does that mean? When I sell a computer, what do I get? Or 1,500, sorry, 1,500. Each computer will sell for 1,500.
Where you're making a profit between the 600 you paid for it and the 1,500 you sold it for.
So I sell it, what does that mean for my company though? I'm at this cash register and I just sold it. Okay, how much money do I get how much money comes into my cash register when I sell it? $1,500 for each computer. Okay. So what we have, I guess what we could think of this is we've got these costs. Costs I could look at as negatives. So that's one cost. Another cost is $600 for each computer. And then in my business cycle, when I sell it, I get $1,500 for each computer. And hopefully I can sell each computer I make so that the X's are the same value. Does that make sense so far? Costs are negative, revenue is positive. It's not, I know you want to jump to when we combine these, that's sort of profit, but it's not really profit because we also have to cover our fixed costs, right? This is our rent or whatever. Okay. Now the final part of the question, we aren't quite done. Write an inequality that can be used to determine the number of computers Sean needs to sell in order to make a profit each week. So when do you make a profit?
Once you've covered your cost plus each computer.
Okay, so all the costs are covered. So when you look at this equation, if I end up with $1 in my pocket, that's a profit, right? So whenever this side is greater than 0, I've covered my costs. Because at 0, that's called the break-even point. Any of you have run a business before?
Yeah. Break-even
Okay.
point, yeah.
Break-even point. You want to.
Yeah.
You have to sell as much as it costs you to do it, and then you made no profit. Or we might not think of a profit yet, but at 0 we break even. After that, we're going to have a profit. So this is something like, this is what they're looking for. This is the expression. Negative, costs are negative, plus this is the revenue. Whenever this side, when the X is big enough that that's bigger than 0, we're in good shape. Okay. Now they actually want us to solve it. That's the easy part, isn't it? I hope. Once we get, this is the hard part to set it up. I agree with you. And we'll do a few more, but that's what you want to think of when you have things that are, you know, basically each computer or per computer. And again, this is on a weekly basis, but each computer, that's where the X is going to go, multiplied. So in thinking through this, what's the first thing you can see to do to solve this inequality? Kind of complicated, a lot of stuff on this left side, right? What can we do with any of this stuff? What about this one and this one? What can we do with those?
Reduce or get rid of one.
You do what?
It's the negative.
That would move it to the other side. So this is, yeah, this is kind of a novel. This is a new one. We haven't done one like this. When the X's are on the same side, what can we do with them? We can combine them. This is where we don't want to be rebellious. This is where we want to do what it says to do. So there's a positive 1,500 and a negative 600. We can combine them by subtraction. 1,500 minus 600 is 900x. And that's a positive 900x.
That's the profit if he sells that computer.
It's the net, but it's, yeah.
It's still not a profit till he pays off the
Right.
2,700.
If we had somebody paying our rent or something, yes. So it's sort of by the it's a marginal profit for each computer. Each time we sell one, we're making 900. So we still have to meet our weekly costs of $2,700. Okay, so that was good. Combine like terms. Now what do we do?
Well, if you divided the 900 or the 2,700 by the 900, it would tell you needed 3 computers in order to make that money.
Okay. But before we do the division, what do we need to do? Okay, good. So this is, yeah, so we move the 2,700 to the other side because we're trying to get the X by itself. Good, and you're going to see exactly what you said is true. So then we get 900x is greater than, again, this was positive, 2,700. And then now what do we do? Now we divide. And that's what you were seeing in your mindset. You could see, yeah, I'll link 3 computers and we're good, right? You could see we were going to divide by the 900. 2,700 divided by the 900. And we end up with is that x has to be greater than 3. At 3, we've made no money. And we don't open a business to make no money.
Right.
It might be, unless we really enjoy making computers, I guess, you know, but we want to sell more than 3. So 4, as soon as we sell 4, we made our 900. So we can see now with our marginal cost.
Well, he has to sell over 300 computers in order just to make a profit.
Right. At 3, then now he can start making his profit. So if he doesn't think he can sell 3 computers, he better not open his business, right? He's got to know that consistently each week he's got to sell 3 computers just to make costs. So he's got to be thinking, I better be able to make it. I better be able to sell 4 computers on average a week just to make some money. If I can sell 5, that's even better. That's $1,800 a week. That's a good income, isn't it? 4 weeks time. That's like getting almost $8,000 a month, a little less, 7. That's an okay income, isn't it? Not bad. Of course, if you could do 6, that's even better, right? So, but this is the type of analysis you can do, right? This is where an inequality comes in rather than an equality. And it says write your answer in a complete sentence. As long as you say it, that's fine. Okay. But what I wanted to show you tonight kind of was this method. Pick out your numbers first, go to the end to see what they're asking about, and then you'll find that sort of naturally working through there, you'll find some way to set it up, but at least you'll know what numbers you're working with. And if you struggle with it, we'll talk it. These are the types of things, though, that are valuable because that's what the real world gives you. They give you word problems. They don't give you an equation that negative 2700 minus 600x plus 1500x is greater than 0. They don't tell you that. They tell you this sentence up, or this paragraph up here, and you got to figure out, what am I doing with the numbers? You know, you're opening a business, you got to figure all these things out. But you can use algebra, and yes, sometimes you've got there's people who have a natural tendency just to think their way through it and come up with the right thing. That's okay, but we're just giving you some strategies to work through these things. And also strategies that help you do it in a way that reduce the stress, that reduce the emotional impact of reading a story problem. And what I've always found is if you read in the beginning, it's like they give you information that's really not important anyway. And sometimes it gets you off onto another track.
It distracts you.
Yeah. It's like, has anyone pulled this one on you about the bus? They're driving a red bus, and 2 people get on at the first stop, and then 3 people get off at the second stop, and then 10 people get on at the third stop, and this and that, and then you're adding on how many people are getting on the bus, because that's what you're thinking. They get to the end, and what's the question? What color was the bus?
Yeah.
Oh, I forgot. I was so busy worrying about adding and subtracting people on the bus. You didn't know what they were asking. That's what word problems do. They start with something and you don't know what they're asking about, so you start thinking about other things. You go to the end of the word problem, you find out what the question is, then you know what to focus on. You know, I don't care about how many people are getting on and off the bus. They're just going to ask about the color or what the driver's name was or something. But, you know, there's all this math problem I didn't need to do. And that's what working word problems sort of in a backwards way can help you with. And again, I found this out by being dyslexic. I didn't do it on purpose. I just found that this was natural. I especially when I was tired, I couldn't read word problems. I would just scan over and see numbers. I say, oh, numbers. Let me write down some numbers. And then for some reason, I like to read backwards. So I read backwards. I go, oh, there's the question. It pays to read backwards. These were things I stumbled on because of a disability, which I found actually helped me in mathematics more than the other things. When I stopped trying to do what everyone else was telling me, which was read the question first, I just did it the way I felt natural about it, I was actually doing much better. And so that's what I tried. You know, some people, go ahead, read it. That's how you want to do it. You think from point A to point B. But for those of us who maybe think, what do they call this? Disassociatively, we get ideas here and there, and we're talking about one thing, and all of a sudden we think about something else. If you're one of those people, that's a gift. Don't let anybody tell you that that's not a gift. It's a strength. Now, they'll say, oh, you can't concentrate. Well, yes, you can. And you'll find that if you work these word problems this way, I think it'll be more natural for you. Pick out the numbers, and as you're picking out the numbers, you're getting units along with it. You're picking out some of the story. Read the last sentence, and if that doesn't have a question, read the one just before it. One of those will have a question in it, and you'll know what you're trying to answer. Then go back and fill in the blanks by reading through the other sentences. And I think you'll have greater success and more fun that way. And you won't get so emotionally attached to, why is Sam opening a business? And is he going to be successful? I really hope he is, because I got a friend named Sean. I keep messing up his name, but that's what it can do for you. Sound good? Okay. We have about 20 minutes left, but I think that took us really all the way through what we needed to for content. So what we're going to work on Monday, I will have a practice test for you. but we still have all day Monday. It's not review yet, but we could kind of start into review if you'd like. We could also go back. We have an extra day. Remember, I started off. I had an extra day scheduled, and I didn't know what to do. We now have an extra day. We got 2 days of review next week if we need it. We can go back to 3 and 4 and answer questions as well.
So we could work on more of the homework. Like,
Yes.
Just to understand it better.
Right. And I'll still live stream. We'll work on problems, but bring your questions. Try to work through the homeworks as you can. Bring questions. Bring things you didn't understand. We'll take a look at them. Monday and Wednesday. Then we got a holiday. And then we got a test where you're just going to really do an awesome job. You're going to ace it. And you're going to lock into these first 4 units and say, man, I don't have to ever do this again, but I want to because I'm having fun, right? And I understand it. But I don't have to worry about it anymore because it's all taken care of. Okay, so if you want to stick around and have questions, be happy to work with you. Otherwise, I'll get this posted. And thank you for attending. It's been great working with you. I'll have the attendance quiz posted by tomorrow. Thanks.